Hello there, Mr. Sutton bringing you this lesson on conditional probability with frequency tables. In this one, we're going to find probabilities using frequency tables, and for a real-life application, we'll use a table to help us figure out the best option for an end-of-the-year party. So, although this is an end-of-the-year party, we're going to make it a beginning-of-the-lesson party. John and Nick are surveying the current sophomore class to see what type of party they want to have at the end of the year. Here are the results by gender, so we've got female versus male. And we've got mini golf, skating, and laser tag. All looks very fun. So pause the video, fill in the table, and say what percent of people wanted each party. All right, so let's see. Which side am I filling in first? I think I'm just going to start up here and work my way down. So we've got a total of 12 people wanting mini golf, 13 for skating, 15 for laser tag, and then doing the totals the other way now. Altogether, there are 20 females. And it looks like 11 plus 9 is 20 males. It's exactly even. How often does that happen? And that means we have a total of 40 students. Now, this total should match going both directions. 20 plus 20 is 40. And then, let's see, this is 25 plus 15 is also 40. So if it doesn't match from one of the directions, you messed something up with your arithmetic. All right, so what percentage of people wanted each party? So we're talking about the total who wanted mini golf out of the total student population. So mini golf, we've got 12 out of 40, which is whatever percentage that is. Could actually do this in our heads. This reduces to 3 out of 10 if you reduce by 4, so that's really 30%. And then 13 out of 40, well, I'll use the calculator for that. That's coming out to about 32.5%. And then we've got 15 out of 40. Also a good calculator question. So I'll just go up here and steal my input from before. And then that's about 37.5%. All right, so that's part one of this warm-up. For the second part of the warm-up, what is the probability, based off this table, that a student who wants skating is a female? Pause the video and see if you can figure this one out. All right, so this one is a little bit tricky. We're not actually asking for the probability that a student wants skating and is female, at least not out of the whole student population, because we're already kind of accepting the fact that a student wants skating, and we're just asking out of the students who want skating, what percentage of them are females. So this is a conditional probability question. This is asking for the probability of female given that you're already just looking at the skating people. And when you're dealing with conditional probability on one of these frequency tables, you've got a limited total number of possibilities for your denominator. You have to use either the end of one of these rows or the ends of one of these columns. So in the frequency table, conditional probability means using the total for a single row or column as the denominator. Here, for example, we're given skating. So that means we need to just look at the total number of people who skated, which is 13. That'll be the denominator for our probability. And then out of them, how many were female? Oh, well, there were 10 who skated who were female. So 10/13ths, which I'll do on the calculator now. And that comes out to 0.769. So the probability of the student who wants skating is a female. If they already want skating, there's a 76.9% chance that it was a female. For the next few problems, we're going to be using this table. So Jamie investigated hair and eye color, and I guess figured out how many people had dark versus light hair, how many people had blue eyes versus other colored eyes, and filled in the table partially. But Jamie was kind of lazy, didn't fill in the whole table. So our first task on this, pause the video and fill in the rest of this table. All right, let's see how you did. So we know that the ends of each row is the total for each row. If we've already got 8 and it adds up to 13, that means there must be 5 people with dark hair that we didn't fill in before. And now we'll do this blank next. We have 15 for this column here. We've already used up 8, so there's 7 left. And now 7 plus 10 gives us 17 people with other eyes. And then whichever way you add, either down or across here, we've got 30 total people. All right, let's move on to now part A and part B. One of the people is chosen. Calculate the probability of choosing someone with light hair. All right, so pause the video and see if you can get that. So if we're asking what percentage of the people have light hair, our total, our denominator, is this grand total of 30 people. So that's what we're looking at. And out of those, how many have light hair? Well, that's the end of this light hair column here. They said 15. So our probability of light hair is 15 out of 30, which is 0.5. Next question. Pause the video and try this one out. All right, let's see if you figured out the probability of choosing someone with blue eyes. So again, one of the people is chosen. The wording is important here. That means, again, 30 is our denominator. Now, out of those 30, how many have blue eyes? So we look at the total who have blue eyes over here. That's 13. So 13 out of 30 is going to be our probability of blue eyes. And whatever that is on the calculator, it looks like that's coming out to 0.433. For part C of this problem now, one of the people is chosen. Calculate the probability of choosing someone with light hair and blue eyes. Pause the video, try it out. All right, so again, one of the people, so that's, again, 30 is our denominator. We're looking at everybody here. Probability of someone with light hair and blue eyes, well, we need blue eyes and light hair at the same time, so that's only 8 people who have both of those qualities. 8 out of 30 is going to come out to, I guess you could reduce this to 4/15, or whatever it comes out to on the calculator, which is going to be 0.267. All right, we're moving on to part D now. A person with light hair is chosen. Calculate the probability of them having blue eyes. So we're not looking at everybody anymore because we're just choosing a person with light hair. So we're only considering the people in this row of people who have light hair. Calculate the probability they have blue eyes. So we're basically asking probability of blue given light hair. So what's our denominator going to be on this one? Well, now we're only looking at the light-haired people, so that's going to be 15 for the denominator. And out of them, only 8 had blue eyes. So 8/15 is our probability, or on the calculator, that's going to come out to 0.533. All right, pause the video and try out the next one. Here we go. Person with blue eyes is chosen. Calculate probability of them having light hair. So we're actually asking for the same qualities we did up here, but we're wording it a little bit differently. Now we're choosing a person who has blue eyes. So we're asking for the probability of light hair given blue eyes. Since we're given blue eyes, that means we have to look for the blue eye total in the table, which is this 13 over here. So that is our denominator for this kind of question. And then out of the 13, how many had light hair? 8. So it's still the same 8 that we had up here, but we're looking at it from a different angle now. It's the number of people who have light hair out of the people who had blue eyes versus the people who had blue eyes out of the people who had light hair. So 8 out of 13 on the calculator. I'm just going to steal my input from before and put a 13 instead of a 15. Comes out to 0.615. For this next couple problems, we're going to talk about children who were asked how they spent their holidays. So we made a chart based off of some of the results. We've got 3 different places you could go: Europe, America, Japan. We've got 4 different housing accommodations: a villa, a hotel, a caravan, that's interesting, and a tent, even more interesting. So pause the video, fill out this table, and then we'll answer the following questions. All right, so I'm going to start up here. This blank I can definitely fill out. There was 22 total who went to Europe, and out of those, you've already accounted for 3, 5, 12 of them, so that means 10 of them must have been in caravans. Moving on to the next row, in the villa, there were 12 people who stayed in villas. We've already accounted for 3 plus 5 is 8 of them, so the American villa people is going to be the other 4. And now moving over here, I don't really have enough information to figure out how many people in America took caravans yet. So let me move on to the next column. For this tent column here, there were 7 people total, and we've used up 7 here, or 10 people total, we've used up 7 here. So there's 3 left for this spot right here. And now I can do this total blank right here. There were 50 people overall, 50 kids overall. We've used up 33, so there's 17 left who made up the total of kids who went to America. And now I can come back and figure out how many who went to America in a caravan. So we've used up, let's see, 9 plus 3 is 12. So that's 5 left over to give us that total of 17. Now we can fill in this box here. we've got 13 minus 7 is 6. And over here, we've got 11 minus, well, the 11 over here, there's nothing left over for caravans in Japan. Apparently that's not a thing. Down here now, our last blank, we have 10 plus 5 equaling 15. And just to make sure that things add up the way they're supposed to, we've got 12 plus 13 is 25, plus 15 is 40, plus 10 is 50. So everything adds up the way it's supposed to. Okay, based off of all this, pause the video and answer the following 2 questions. All right, so for the first question, now they said one of the children is chosen, so that means we're looking at this grand total of 50 for a denominator. We want to know that a child stayed in a hotel. Let's see here. So we have a total of 13 kids who stayed in hotels out of a total of 50 overall. So 13 50ths, and I can do that on the calculator. That's just without a calculator. We're just dividing by 5 basically. So that's going to be 0.26. And then a child stayed in a tent or a caravan. So again, it's a grand total of 50 for the denominator. Now tents and caravans combined make up 25 of the total. So that's 15 plus 10 out of 50, or 25 over 50, which is exactly 50%, so 0.5. All right, we've got another 2 problems here, parts C and D. So a child who went to America is chosen. Calculate the probability that they did the following. Pause the video, try it out. All right, so if we're choosing a child from America who went to America, that's 17 that we're going to be using for our denominator now. We only care about the ones who are in this row. So probability they did not stay in a hotel. So not hotel means everything except the 5 here. So that's the other 12 children we're talking about out of 17. So that comes out to what on the calculator? 12 out of 17 on our calculator comes out to 0.706 if we round off. And now we've got stayed in a villa or a tent. So now we're asking for probability of villa or tent given America. And what's that going to be? Well, here's villas, here's tents, here's America. So we have 4 plus 3 out of 17. So 7 out of 17. And on the calculator, let me just go back up to that input from before that had a denominator of 17. And now we're going to say 7 out of 17, which comes out to 0.412. For our last example, we're going to do something a little different. 80 children went on a school trip. They went to London or New York. 23 boys, 19 girls went to London, 14 boys to York. We want you to create your own frequency table using this information. So pause the video and see if you can figure out how to do that. Note that you're going to need, rows or columns for London versus York and boys versus girls. All right, so setting this up, we have to do it one way or the other. I chose to make the first row boys and the second row girls. Certainly you could have switched those. I chose to make my first column London and the next column York. Again, you could have switched that. You could have had a London and a York row and a girl and a boy column. It doesn't really matter which way you do it as long as you're consistent about it. But given this particular setup for a frequency table, I need to start filling in the information. So the first thing I see here is that 80 children went on a school trip. So that's my grand total down here. Everything needs to add up to 80, going this way and going this way. They went to London or York. All right, got it. 23 boys and 19 girls went to London. So that means we have a 23 in boy London, and we have a 19 in girl London cell right here. And now 14 boys, they said, went to York. So that's a 14 right here. And they didn't give us anything else, so we need to fill in the rest of this. Well, I know that if we had 23 boys in London and 14 in York, that's a total of 37 boys overall. And let's see, I don't have quite enough to fill in this part yet. I don't know how many girls went to York. I need to find the total girls first. So if there's 37 boys and 80 students overall, that means there's 43 girls, 80 minus 37. Now I can go back and figure out how many of those girls went to York. 43 minus 19 gives me 24. Down here, that means we had a total of, let's see here, that's going to be 42 children going to London. And that means we have 38 kids going to York. And if you do 42 plus 38, that does indeed add up to 80. So we got it. This concludes our lesson on conditional probability with frequency tables. If there are more advanced questions we need to know, we will have to table them for later. Till next time, Mr. Sutton signing off.